Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. This should be a familiar face for you. This is the Sansui A-550, my mule. Today we're going to do a little bit of testing here. So let's select our first victim. What are we going to do? Let's have a look at these. All right. So what do we got here? What do we got here? 4865, 4853, or 63, 4843, 4843, 4343. Okay, so I have 4 of these 4853, sorry, and that's what's used in the Sansui. These all look legitimate to me. They have different, what I assume are date codes, and they're all different, and they all look legitimate. These ones have 4843 on the back. Well, this one says 4863, so this one might be something else. 4843 EJA5, 4843 EKB3E, 4843 EEC7E. These look like not lot numbers to me. This one here doesn't make any sense, as it's 4863. And if I look at the back of these two, I got nothing. These ones here, these ones are potted. Interesting. These ones have stamped, let me show you. These ones have stamped numbers on the top. 4G24, 3B26, and then they have the other number here as well. These ones don't have that stamped number on top. And they have they're different in regards to how they're potted. This one has a plastic filler, this one's potted. This one's got heatsink compounder on. Maybe it's a used pole, but I don't see any. Maybe not. Could be a used pole. This one here looks clean, looks new. So we might have a used one here that I purchased. It looks pretty beat up too. It's all scratched. So let's start with one of these. If these are counterfeit, they're pretty good ones. They have, you know, numbers that don't match. So then they have, looks like lot numbers on the back. This one's got heatsink compound around it. So this one might be used. Same with this one. And this one. And this one. So these might be all used, but they don't look like they've been soldered. Well, that could be deceiving. That could have been cleaned off. This one's got some corrosion on the pins. And yeah. So I think we should just go start with one of these. Which one should we go with? They look like they could be all used. Let's try one of these. Let's try this one. Okay, before we get any farther, let's have a look at the data sheet for the STK 4843. It's all in Japanese. I can't read it. It says 2 channels, 30 watts minimum. Okay, and we're just basically looking for some specs here. VCC max is plus minus 43 volts. This is the thermal resistance of the heatsink. Temperature junction, TJ, is 150 degrees Celsius max. Temperature of the case, TC, will be 125 degrees max C. I guess that's the one we're going to target. Temperature, I think this is storage. Who knows? Okay, so it doesn't really tell us much here. Idle current typically 70 milliamps when it's powered on. THD is 0.02%, 20 to 20 kilohertz. I find that hard to believe. Let's see. Power at 1 watt, 0.2%. And that's it. Okay, so they even give you a little power supply, how it should be, 4700 microfarads for the power supply. Gives you more up. It gives you a schematic of the internals, and then it gives you an application note of how to use the chip. You got half a channel there, or half the chip there and half there. This is in bridge mode though. Oh no, this is input, input, output, output. Okay, so that's 2 channels. So I guess what we're looking for here is this. Temperature of the case, maximum temperature of the case, 125 degrees Celsius. Let's target something like that first. So what I plan to do before I install this dubious chip is we're going to baseline test this one. We're going to put it up to full power. We're going to monitor its temperature, how long it takes to get up to temperature. We're going to monitor the current consumption of the amplifier. We can calculate from that how much power is going into it. And from our measurements we can determine how much power is coming out of it, and how efficient this is. So let me get set up and then we'll start that. Okay, so we're set up. This is my ambient temperature of the heatsink right now. Pretty sure you can see that. Good. And this will be our power consumption. Can you see that as well? Okay, you can. So let's turn everything on and start everything going on here. We should have it on the scope. Let me get my scope set up. Okay. So basic power consumption with no signal, 12.7 watts sitting at idle. Let's turn this up and let's start getting our signal going here. Take this up to clipping. Right there, let's back it off a bit. And let's just monitor this for a while and see how it's doing. We're putting 150 watts, 152 watts into the amplifier. And we are measuring, let's see if we got this at peak. We're measuring 16.25 volts RMS output. Now it's just a waiting game. It's a kind of interesting note here that I did the calculations. We're getting 33 watts per channel output, and if I subtract that from what we're delivering to the amplifier, that's 86, 87 watts that's going to be dissipated by this equipment here, this electronics, and it's slowly climbing up. Another thing I noticed is the amplitude of the signal is climbing as it warms up, so I'm going to turn it down a little bit because I don't want it to be in clipping like it is right now. Turn it down a touch, and we're roughly at 55 degrees Celsius, climbing. Just wondering how far I should take this heat. Should I take it up to 75 C, 100 C, 125 C? I have a feeling it'll probably blow out before 100 degrees C. So maybe if I go to 75 or try 85 degrees, that should be good for an initial test. Let's see how long it takes to climb up there. Alright, there we are. We're at 75 degrees and it's still chugging along, still put out the heat. Nothing exciting has happened yet. Current consumption stayed level our power output stayed level, and it just continues to climb in temperature. I gotta hand it to this little Sansui. It's a little tougher than I thought, but then that's all up on the STK module. I don't know if these things are temperature compensated or not, temperature protected, but it seems to be holding out. It's climbing up to 80 degrees Celsius. I'm really curious is if I could blow this amplifier up by running full power to it for an extended period of time. And you know, the temperature, we're radiating a good amount of heat here. This little tiny heatsink seems fairly efficient. And we're coming up to 80 degrees Celsius. This heatsink here is quite warm. It's quite hot to the touch. But it seems like the climb is slowing down. Seems like it's hitting an equilibrium of dissipation with regards to the amount of current going through the device. I think I'll shut it down at 85C if we can reach it. Another thing I'm not really paying attention to here is time. I wish I had a stopwatch or something I could put in field and you could see how the time's evolving, because I'm probably going to edit this down. It's going to be a long video, so I'll edit this down. Looks like it's having trouble getting up to 80. Our power output has dropped, actually. It's down to 15.47. It's quite a substantial drop, actually. So maybe it is self-regulating. So now we're down to 29.9 watts on the output. Okay, I think I'm going to call it there. It's 81 degrees Celsius. Doesn't seem to be climbing at a very high rate. It's very slow at getting up to temperature. So I'm going to shut this down. And now we're going to let it cool off. We'll install this one that I purchased on Aliexpress, and we'll see how this goes. Transformer is quite warm too. Don't want to smoke the transformer for sure. This one has no date code silkscreen on the top corner. It has a stamp 3H20 and it's got the lot number on the back 4843 EGB7. So I'm pretty sure this is a legitimate original STK module. Okay, very curious, the pattern here when I took the STK module off. You can see the clamping force from the screws here and here on the heatsink compound, but it looks like the majority of this, 90% of it, didn't even make contact, if you can see that. And looking on the heatsink, this kind of confirms it too, because there's really no contact with the module in some spots, and you can see it made contact near the screws. So I obviously didn't put this together properly when I worked over this amplifier, and it survived the torture test just now. So I'm kind of impressed by this, considering we were only making contact on this side and this side of the module with the heatsink. This side and this side. So let's see if we can get this one in a little better without what I'll do is I'll blob it in the center and allow it to spread on its own. That should be enough to allow it to spread. Alright, we got our test chip installed and we are going to test it now. We got everything hooked up, I believe, except for our power. So let me plug the power in. Let's turn this on. Ooh, something popped. What was that all about? What happened? I heard a noise. Anyways, do we have an output? We're drawing 12 watts. What is going on here? Looks like we might have to do some troubleshooting on these eBay chips. I'm getting nothing on here. Let me see if my settings are all correct. Ah, there we go. I'm going to check my probes, maybe one of them came off here. I think that's what happened. The probe is working. It looks to me there's a problem with this amplifier. 130 watts. What is going on here? Shut this off. There's definitely something wrong with this amplifier. Okay, so we're drawing 130 watts, no signal. When I turn it up, we get clipping, and we are at 14.93 volts RMS. Something's dragging the power supply down, and I have a feeling it's that right channel. 180 watts. Where's all that power going? The right channel's not working. I have a feeling I know what's going on here. I think I got DC on the output. Let me check with a meter on the right channel. Let's check here. Let's see if we have DC on the output. I have a feeling we do. Yes, we do. We got full power on the output, 24 volts. So that would smoke your speakers. That's where our power is going. So let me disconnect the load for the right channel, since that amplifier is buggered. Let's put this aside, and our power consumption has dropped. Okay, so let's go full power on the left channel. We're going to get slightly better power output because we are driving one channel only. So I think right about here is our maximum. And we got 17.92 volts RMS. It's going to allow things to warm up and cook here for a while. Okay, we're about 15 minutes into this, and since we're only driving one channel, our input power is 88 watts, 88.5, and our temperature rose up to 65 degrees Celsius. And it's kind of stalled there. It's probably going to go up a little bit more, but I have a feeling we hit an equilibrium here with the heatsink. Yeah, there we go, 66. So it could be a long try before we get that temperature to go any higher. But this is a fail anyways, because this one module has a dead channel and it's dumping DC or rail voltage onto the speaker terminal. So yeah, it's a fail. Okay, we're still on full power here and it's powered up. Have a look at that capacitor there in the center of the screen. Top is all puffed up, and that is a brand new capacitor. I'm not sure which channel that is, but I have a feeling that could be the right channel. But that capacitor looks like it's ready to pop. Yeah, I just shut the power off, and that cap is hot. I'll put my fingers on it. Quite a bit of heat built up in that cap. All the other ones are cool, but that one is definitely scorching. I'm going to trace that to see if that's the right channel. Not only is it dumping DC on the speaker terminals, it's destroying the caps in the circuit. Okay, here's the cap with the bulgy top removed. This is a 47 microfarad at 50 volts, and it's measuring out at 35 now. It should have about 1.5 ohm, or sorry, should have 0.5 ohms or less ESR. Now it's up around 1.6. So this cap is definitely damaged beyond use, so I'm going to replace it. Alright, so let's have a little chat about what happened here. This module failed, or it was a defective module when I put it in. It was dumping DC voltage onto the output of the speaker terminal. And if you look here, this 47 microfarad cap was connected to pin 13, which is the right channel output, and it was getting a negative voltage applied to the positive end of the capacitor. And I think that's what happened here, is we were reverse polarity on this capacitor. It had 26 volts on it, and it just destroyed it. Now I tried looking at this with a magnifying lens. I couldn't see if this vented or not. If there's cracks in the aluminum, then it's possible it probably vented. But then after I took the cap out, it seemed like the dome on the top went down a bit. Let me see if I can push on this. Yeah, you can push on that and it goes back. Hang on a sec. I think I just saw something squeeze out of it. Yeah, it's leaking for sure. So yes, it did vent and it did pop. Okay. So that's garbage. I replaced it. So we had half a working amplifier here. The right channel was dead. Probably one of these output transistors. Well, we know that it was probably the negative one, the one from pin 11. Pin 11 is minus VCC. Pin 11. So this transistor here was shorted and dumping DC onto the speaker output. Now I have a feeling I know what's going on here now. these modules that I bought on Aliexpress, I have a feeling they're used, and I'll show you why here in a second. Because when I, there, now that's how it's supposed to be spread. Now when I originally looked at these, you could see the white heatsink compound in the crack. That was even before I put it down. So let's have a good look at this one. I think they're legitimate modules. I just think that they're used. Let's take this off. Let's take this one off. Let's have a look inside. Okay, how do I do this? I don't want to destroy the innards. Let me try this. There we go. Try this side. There. I think we got it. Yeah, I don't want to destroy the insides. Have a good look at this. Wow. Very brittle. Okay. Okay, so those leads are epoxied in there. I'm not going to take the bottom off. I think we got enough off that we can see what's going on here. So there's our 4 output transistors. It's split down the middle, left and right. So we got an amplifier on one left side, amplifier on the right side. Let me clean up here and then we'll get a good look at this. Okay, let's have a look at this module up close. Let's see what I can do here with my microscope camera. You see it's a typical construction. It's got like a phenolic board. No, it's actually not a board. It's some kind of a layer. It's all put on a aluminum plate. So we have an insulating layer, and then they have these copper traces etched in this thing as like a printed circuit board. Then they have bond wires jumped everywhere. You can see some of the bond wires here. And go down a bit, there's a big MLCC cap soldered in place, and it looks like there's a little bit of damage here in the upper corner. Maybe that was from when I opened the case up. If we go down and look here, we can see transistors. Pretty sure those are transistors. Let me see it. Get a good focus on them. Yeah, they are transistors, all right. They could be diodes too. But usually when they're mounted like that and you have 3 connections, it's a transistor. Transistors, transistors. Probably right here is the input section somewhere. It's coming up, those 3 lines coming up the middle. Probably comes up and it goes up to like a differential pair or something like that. It's probably standard architecture, amplifier architecture. So let's have a look. See, these ones here are the drivers. These are mounted on a little plate to dissipate extra heat that they need, and there's 2 of those on each. So I'll go down here and look at, there's another one here. So those will be the drivers, and then these are the output transistors. They're mounted on a solid block of aluminum. Let me focus this a bit better. And these are quite heavy-duty current transistors, even though in real life they measure probably 2.5 millimeters across. You can see that they are diffused, and yeah. So you got your bond wires there, and then the collector, I believe, I can't remember which one the base is. So we're looking at the left channel right now. I'm just going to go down and look at the other transistor here. Everything looks normal. Well, the left channel was working normal and everything. So let's go look on the right channel. Right channel, we have a blob of something on the transistor. I don't think that is anything that's... Let me see if I can knock that off with a pen or something. It's just a blob of silicon, I think. Don't understand why they have this stuff. Okay, let's go look at the other transistor. Oh, and we can see some damage here. We got that bond wire on the left is completely burned off. It looks like. Let's see if I can hook that bond wire. Screwdriver. Yeah, it's not even connected. See how it's... Bond wire is not connected. It's connected with the silicone. Let's get that out of the way. Yeah, if we could clean that off, we would see the damage underneath. It's not looking pretty for this transistor. There we go. Can we get that off? So there it is. It looks like it bluted a hole in the middle. Okay, so that's one of our problems. Now I noticed there was something here. There is something here that used to be a resistor. This thing here is charcoal. Because if I go and look on the other side, you can see the resistor here. You see it here. And this one's charcoal. So let's look at the drivers. Maybe we can see if the drivers are bad too. I don't see anything wrong with that one. And you can't really tell by looking at it either. Let's look at the bottom one. That one looks okay too. And that's it. Pretty much it. You can see you got resistors here, resistor there, resistor here, resistor here. But that's it. She blew it up. Okay, well there's the first one. It's not really surprising. So I'm coming to the realization what I bought here is a bunch of used chips. So this one here is another one I purchased. And I can see two marks from where there used to be screws. So this is probably another used one. And then you can see it's got the heat-seek compound, a little bit of it peeking through here and there. So they didn't do a very good job of cleaning them off, and they look fine and everything, but let's pop this one in next and see if this one has any problems. Okay, let's power this one up. Alright, I think we're ready for our third test, or second test, whatever it is. Let's power this thing up. And this one popped too. It popped the fuse. Unbelievable. Okay, let's pull the power off. Fuse. Yeah, what is this thing? 2.5 amp. It's definitely a bad module if it's popping a fuse like that. So I guess that's a fail as well. Didn't even get to this power test. Okay, what happened to this one anyway? So we got an ohm meter here. These are the filter capacitors. This is the ground. This is negative, so this would be positive here. And we are getting 300 kilo ohms, no, 300 ohms. Kilo ohms, so that one's okay. Let's check this side. Oh, that's negative. Okay, so that's positive. It's negative. Looks like we got a dead short. But no, it's coming up to the hundreds of ohms, kilo ohms. So basically they're both the same. Why did it go into short circuit? I'm going to check my connections. I don't think I did anything bad here. Everything looks good. No solder bridges. There's no reason for that to blow up like that. Okay. Let's check some more things. Speaker output's right here. So this one here and this line here, because there's a jumper and it goes out this, and then these are grounds. These two are grounds. This is one channel, that's the other channel. So if we go back to here and measure to positive, you got 3.5 ohms. Let's measure to negative. Got 1.3 ohms. Okay, so where is my other speaker? Right here. This one. We got meg ohms. Okay. This one. Meg ohms. So this right channel's buggered on this one as well, but it's a dead short between positive and negative, I think. Let's check this here. Four and a half ohms. Putting 50 volts into 4.5 ohms. No wonder it blew up. Okay, well that chip is no good. Let's remove that one and have a look at it. Well, this one's going to be tougher. We'll get this. Yeah, don't worry. There we go. Let's have a crack at this one. It's the same kind of material that they used on the last one I tore apart. It's kind of a fibrous, I don't know what you call it. It's got fibers in it. It's probably like some kind of epoxy or something. So this one all looks very normal. A little different construction to our main transistors. If you remember, where was the other one? You can see how the transistor's a little different. Let me check a few things. Seems like our right channel is giving us grief, so let's check. Let's see if we can find. That's a dead short there. Dead short there. Dead short there. Yeah. Look at that, eh? There's a normal transistor. I think. I don't know. There's no dead shorts on it, that's for sure. That might be all normal there. Let's check this one. That's silicone stuff. Not seeing normal readings. Let's have a look at it closer. So this is the left channel again. Everything looks normal here. Everything looks good. Here's the driver. Here's the other driver, and here's the outputs. That one definitely looks okay. That one definitely looks okay. Let's go to the other channel. This one here looks... That's a blob on there, or what is that? Something in the silicone. I have a feeling. Let me try removing this. Some kind of conformal coating. Okay, let's look at the other one. Ooh, and this one is carnage. Yeah, this one's bad. Ooh boy. I bet she got hot. Oh, they're both disconnected. Wow. It really took a hit. And the die is just shattered. Look at that. Okay, so there's a problem there. This is what we're getting on Aliexpress, eh? That's what we're buying. Used stuff that's damaged. Let's have a look at the rest of this. Can't really tell if this one's okay. Bond wires are attached. Maybe not. Well, they were attached. Okay, let's look at this one. Bottom one. Really hard to see these small ones. I wonder if I go in closer. Hang on. Okay, we can get a good look at them now. That one looks alright. Let's try the other one again. This one looks alright. This one was okay until somebody mangled it. Look at that mess. I'll hold it still so you don't get sick. Stuck to my fingers, sorry. Okay, let's focus this. Yeah, look at that mess. This one's damaged too. Looks okay. And that looks okay. Eeny, meeny, miny, mo, catch up. I think you're next there, buddy. This is more of the same. Heat sink compound. Heat sink compound. These ones here, I think, are new. These ones here, I'm pretty sure are used. You can see the back here is pretty deemed up. Which one did I pick? It was this one, wasn't it? Yes. Okay. Isn't it fun watching soldering? All right, let's try this again. You think she's gonna pop again? I don't know. Let's see. Good chance of it. So we got a new fuse in. We got a new module in. Got everything hooked up. Our load, voltmeter, scope, everything. So let's turn it on. Oh, this one's gonna work. 13.85. Okay, so either we got one dead channel or two good channels. Let's try this up. Hey, how about that? Look at that. We got a working chip. Okay, let's turn this to clipping, and let's get a reading on the output. Right there looks good. Drawing 151 watts. Looks normal. 16.13 watts on the output. We'll just let this go for a while and see if we can pop this one. Problem is, this transformer is getting quite hot during these tests. I think this is undersized for what I'm doing. I just don't want to pop this transformer because it's a fairly good transformer. It's 0 to 27 volts center tapped. Let's try and keep this transformer alive. The chips I don't care about. The modules, we can pop them all day. I'll go buy more if I need to. But we got a runner on this one. This is good. So what's our success rate so far? 33%. Let's get this thing warmed up. Making contact. Oh, there we go. This wire is buggered. Okay, you win. Well, we're like 9 minutes into this and it's starting to clip a little bit. So I'm just going to turn it down a bit just so it's not clipping. Right to there. And our power output dropped to 15.45 volts RMS. Temperature's climbing to 73. Just going to let it keep going. Okay, this has been on for 15 minutes now. I'm going to shut it down. The temperature is pretty much plateaued at 79, 80 degrees. It's not going any higher. It's just really slowly climbing. And all I'm doing now is I'm just cooking the power transformer and it is getting really hot. So this chip has proved itself. It's a good one out of the batch. Let's test the last one. I'm going to have to let everything cool down first because this is just torture on that poor thing. Okay, so we finally found one that tested okay. So I'm going to keep this one in my part stash if I ever need one for a future repair. Let's test this last one out. I have a feeling it's a 50-50 chance. It might be bad, might be good, I don't know. I'm beginning to think those first two, these first two were used, they were definitely used. Now, I don't know about this seller and what kind of policies they have on returning broken used chips, but I have a feeling these were returned and they were sold to me as functioning when they weren't. Maybe somebody scammed the seller by returning these and saying they didn't work, but in fact they were returning their broken ones. I don't know. But let's give the seller a chance and to redeem himself, and we'll try this one out and we'll see how this one goes. I have a feeling it might work. Can't all be bad, eh? All right, here we go, test number 4. So let's we got everything set up properly, I believe, from last time. Just turn this thing on, see if it pops. Watch the watt meter. Went up to 20 some watts and settled back down at 14. Everything looks good. Let's turn up the volume. Signal on both channels. It's a good sign. I need to turn on my voltmeter. Okay, let's take it up to clipping. Back it off a bit. And we have 16.47 volts RMS. And we'll just do the waiting game now. Okay, we're at the 15-minute mark here, and this one survived. And we can see the temperature plateaued around 78 degrees. Might go a little higher if I leave it on, but again, I don't want to cook the transformer, it's already hot. So I'm going to shut this down. We got another keeper. Well, how about that, eh? 50%. Okay, here's my Aliexpress order history. This is where I bought these from. These are the two I bought, the 4853 and the 4863. I bought them at the Wisen Tech store, and I paid for both of them. I paid $16 shipped, and I ordered these back in January 2022. And if I go here, it looks like the details are missing. If I go here and if I look at this, price has gone up. They have STK 48, 43, 53, and 63. Free shipping. I wonder how many you get free shipping. 10, 11, 12, 15. Get free shipping on all of them, but they're charging you $10 or $10.50 a piece. If I go down, the all module store, this is where I bought the 4 STK 4843s. Now, 2 of these were defective, 2 of them worked. So I paid $8.83 a piece for these. If I go back now, the price has gone up to $9.24. I think I might add a couple of these to my shopping cart and order some more, and just to test them out. But yeah, like I said, this all module store, this is where I purchased these. 50% of them were good, 50% were bad. Let's see the pictures here. Pictures don't even do it justice. This here is not the way it looks when it arrives. That green printing. 4913 CH. Yeah, they're showing a... Okay, let's go down. Oh yeah, great shopping experience. Here's some pictures of it. It does look identical to this. It's got the notches here at the bottom. See the notches? It's not epoxy filled. It's got like a stamped on date code. And if I go down, this is the 4913. This does not look legitimate. That's not factory. I think that's stamped on there by somebody else. Let's go down. Yeah, everything's 5-star. Everything's cool. Okay, so I think I'm going to order a couple of those more. A couple more of these 4843s just to test. And let's get a different supplier here. Here's a cheap one from China. It's a 4843 from Sanyo, $5.88 plus another $6.50 shipping. So it's pretty more expensive than Aliexpress, but it has the same kind of photos. Let's have a look at this. It says it's a new Sanyo STK 4843 2-channel amplifier. Doesn't give you any other information. Let's look at the pictures. Let's go look at another one. This one here, I think I might try. It's $11. That's $15 Canadian. That's a lot. But it's in the name of science. So let's make an offer. Okay, so let's make this guy an offer. Let's see here. Let me get a calculator. Okay, let's try buying one of these here. This one here, I don't know if it's any good or not. Chipsgate. I think I might have bought from this seller before and I've had good results. The thing I like about this listing is it uses different pictures from everybody else. Okay, so I have a feeling it's probably from different stock. So let's make him an offer. Let's make an offer US $9. And let's just put this as final offer, and let's just send that away. Yep, you betcha. Done. Okay, let's see how that one turns out. Here's one from the UK. They're asking probably, well, a lot of money here. $45 Canadian. Plus shipping. This isn't a very good listing though, because the shipping is in Australian dollars. This is a UK listing. But Nyko Electric, I've bought from them before and I think I've had good results. This is probably legitimate, but it's also high priced too, right? Okay, that leaves these two beauties. I got a 4853, 4863. I looked for data sheets for this 53 and I can't find data sheets anywhere on it. It doesn't really say. I did find one for this. Let's have a look at it. I can't really tell the difference between these different parts. Let's have a look at the data sheet. Okay, so here is the two, 4843, 4863. They look identical as far as specifications except for one thing. This is 35 watts, this is 30 watts, okay? And from that, I derived that this has an input voltage of plus minus 27.5. and this one has an input voltage of 30 volts. That's the only difference I see between the two of them, because if I look at the other pages here, what do we got here? They look identical, application notes and everything. It looks identical. Let's see, the circuit looks identical too. I don't see any differences here between the two. Everything's pretty much probably just a beefier version of the light ones. Okay, so let's, in this one here I didn't find any data on it at all, and it says it's a 30 watt amplifier. So what's the difference between a 43 and a 53? I don't know. These ones don't have the markings on the back. This one's got a little few dents, so it looks like it's been beat up. This one looks relatively new, except we have smeared paint on the front. This one's pretty chewed up on the front, like it's been beat up. And it has heatsink component in the crack here, so I'm assuming this has been used. This is dirty in here. Yeah, so this is a used module. This one looks a lot cleaner, and I'm assuming this one's new. So let's see here. Let's say this one's going to die, this one's not going to die. Shall we try them out? Okay, we got test number 5. We're testing a 4853. Here we go. Turning it on. Here we go. Power shot up. It's going down to 18 watts. Looks normal. Yeah, let's see what we got. Signal on both channels. That's good. Clipping. Back it off a bit. And we're at the 1 minute mark, so I'll just let this go for a while. On our output, we got 16.2 volts RMS output. Okay, so we're at the 15-minute mark here, coming up in about 20 seconds or so. Behaves exactly like the other ones. Heats up the same, consumes the same power, but then of course we're using the same transformer. And power output right now is, let's see here, it's still clipping a little bit. I just gotta knock this down a bit. It's just barely clipping. 14.92 volts RMS on the output. So as they heat up, they produce less power. So this one's another keeper. The 4853, it appears to be working good. So let's try the last one and see if we get the same results. Okay, here we go. Sixth and final test of the STK 48 series. 4863 coming up. Gonna bolt it in, solder it in, thermocouple's connected, everything's ready to go. Let's try this out. I put the fan on the power transformer for about 10 minutes to cool it down because it was getting quite hot after the last run, and it's down to room temperature now, so we should be able to go good on this one. Let's see, let's turn it on. Power shoots up to about 28 watts and drops back down to 14. So everything looks good. I noticed this one consumes less power than the last one. I think the last one was 16 watts. I have to review the video to see. So where are we at now on the counter? Okay, we're at the 1 minute mark on the video. Let's turn up the volume. Okay, so that's clipping right there. Same as the rest of them. We're at 16.10 volts RMS output. Even though this chip's rated for 5 more watts, we're still using a power supply that can only supply so much power before it starts to clip. So not much we can do about that. It's supposed to be a tougher chip, a little more power dissipation. I think what I'd like to do is a 4 ohm test on these to see, because we're not getting a lot of heat on the heatsink. We're getting 80 degrees Celsius, which is pretty mediocre compared to you know, what it takes to actually blow up a chip. But yeah, I think 4 ohms, but then I'd probably end up cooking the transformer. I don't think it's rated for that. I think it's just it's a poor choice. Well, not a poor choice. I think it was just sized appropriately for what this is, right? So yeah, it's not going to have a lot of big piles of power behind it. It's got like a tiny transformer. So anyways, let's let this cook for 15 minutes. We'll see how it turns out. Okay, we're at the 15-minute mark, and it's pretty much a repeat of the other 5 tests. No, actually it's repeated. It's 4 tests. So I'm just turning this off. Seems like that one's a keeper too. And we'll take it out, and then we'll talk about what we found. Well, there you have it. That's the results. I bought 6 dubious STK modules on Aliexpress, and out of the 6, 2 of them are duds, and the rest of them seem okay. Now, I hear a lot of people say, "Oh, anything you buy on eBay is counterfeit." You know, like, no, this is. I don't think these are counterfeit. I believe these are new old stock, or they're used, and I think they're okay. So, my advice to you: if you're looking for one, try it. Buy one. If it doesn't work, buy another one. I don't know what the solution is, but I think I was sold used broken units here, and these are all. I think these are all original STKs. I do believe they are, just from the construction of them, and I don't see any difference from an original that came out of the amplifier. So my advice to you is buyer beware, and you know, I think we learned something here about this. You know, not everything you buy is dud. So, blown fuse, bad cap, and 2 blown modules, but the rest is good. I hope you found this entertaining, informative. Maybe it helped you out. I don't know. Like I said, if you are looking for one of these modules, give it a try, because these do look original. Okay, that's it for this one. So thanks for watching. Take care. We'll see you on the next one.